Hello and welcome. The topic of this video is about the charts selection. In this session, we will introduce the basic chart types that we often use in practice. We know graph is a great way to visualize the underlying data, but do you know what are those basic plots we may need to master in order to effectively visualize our data? We will cover in detail the 8 fundamental plot types. They are the line plot, the histogram, the scatter plot, a bar plot, box plot, pie chart, a map, and bubble plot. They may not be comprehensive for data visualization, but if you know the rationale behind each basic plot, you essentially get to know the data visualization tips and techniques, and you can create your own storytelling. So let's start with a single-dimensional data variable, a quantitative data variable. Say you have collected the data for different household incomes, and how will you visualize that? You may want to know the distributions, right? So for data distributions, we may using the basic chart type, that is the histogram or a box plot. So what does a histogram tell us about the data? The histogram divides the range of numerical values into the bins and displays the number of data values that falling within each bin. A good bin weight can balance information loss and useful data aggregation. It can show the distribution of numerical variables. You may observe many other data patterns in a histogram. For example, the central tendency and the skewiness. Some are symmetric, some are positive skewed, some are negative skewed. You may also easily see the outliers. An alternative way to graph one-dimensional numerical data is to using the box plot graph. Box plot is especially useful when you need to describe the various percentiles. For example, like the median or the 50 percentile, that is the point at which half of the data lies. The 25 percentile, the 75 percentile are the values below which 25% and 75% of the data lie. You may also see the outliers clearly, the upper extreme and lower extreme. Histograms are very useful for summarizing numerical data in that they show the rough distribution of the value, and a box plot is often used in conjunction with the histogram. Here we show some similarities between histogram and box plot. You can view the central tendency, the skewiness, very easily in both graphs. Let's move to a single-dimensional data variable, a qualitative data variable. Say you have one column of gender values, and how will you visualize that? We have 2 or 3 different values for the gender, the male, the female, or others. So for a bunch of such records, it would be necessary to aggregate them by the different categories. See how many females and how many males. In that way, we are creating some auxiliary measures for this qualitative data variable. So the possible basic chart type you can use is a bar plot or a pie chart. But the pie chart will actually show the percentage to the overall. So for a bar chart, we can put the different categories along the x-axis and y-axis indicate the aggregate measure for each category. See, that is the total count here. For a pie chart, we can put the different categories with different angles, and angle degree is the percentage value to the overall. What if we have multiple dimensional data? Say you have one column of qualitative data and one column of quantitative data. And for each category value, you may have multiple quantitative data points mapping to that. We see the mapping is 1 to m. So in that sense, each category value have several quantitative data points. So we would like to know its distribution individually. So for data distributions, we may use a variation of the box plot. So for this given data table, data variable, the rain day is a qualitative data type, and the pressure is a quantitative data type. For each category in the rain day column, we have two values, either a yes or no. So if yes, in the pressure data column, we may have many data points, so it makes sense to characterize the distribution individually. And we have this resulted box plot where two distributions are displayed. We may easily compare the distribution of variables. Here is another example. We have two columns of data variable, and one is the qualitative data type, the department, and the other is the base salary of individuals working in that department. So we may use box plot to compare the different distributions among the category marketing and research department. How about this data table here? For each category value, the state in US, you may have only one quantitative data point mapping to that. We see the mapping is 1 for 1. In that sense, each category value have only one quantitative data points, so we don't have the distributions. So to display the data mapping, we may using a bar plot, or we can using a map view, since the qualitative data is also a geographical data type, the state here. Here we're using the map graph to display the unemployment rate across locations. For each location, there's only one unemployment rate. How about the case we have two columns of quantitative data variable, somewhat like the data table given here, X and Y. In that sense, we would like to know the relationship between X and Y variable. So you may refer to the basic chart type like the line plot and scatter plot. The simplest way to graph one-dimensional numerical data is to graph them as points in a two-dimensional space, with one coordinate corresponding to the index of the data point and the other coordinate corresponding to its value. Once plotted, you may observe the relationship between the two data variables here. The common patterns we often find in a scatter plot is the correlation. For example, like the positive correlation, the negative correlation, a nonlinear correlation, and even no correlation here. How about a line plot? You are given the two columns of data. One is the time index, and the other is a value variable, could be anything. Line plot is a type of chart that is used to visualize the value of something over time. For example, a finance department may plot a change in the amount of cash of the company that has on hand over time. We may observe the cyclical pattern as we see our macroeconomies. We may observe the trend. Say in the stock market, you may trace a certain stock over time. You may also compare a few line plots together. Say compare a few selected stocks over time. Well, since both line plot and scatter plot are used to describe the relationship between two quantitative data variables, are they the same? Let's compare two examples. The first example is about women weight in different height. Is it a line plot or a scatter plot? The second example is also women weight in different height. So for this one, is it a line plot or scatter plot? What is the differences here? You may pause here and think about it. Clearly, in the first plot, we have described two women over time, and you may consider for each woman we have been tracing their own the growing up journey over time. As time goes by, their weight and their height are both increasing. So this is actually a line plot. As in the second plot, we have In the second plot, we have collected several women's weight and height that may happen in a fixed period. We can see an obvious positive correlation between women's height and weight, and this is actually a scatter plot. Do you have the right answer? So we have described for single-dimensional and two-dimensional data variables. What if we have more than three-dimensional data variables? Can we still describe them in a single plot? The answer is yes. And remember the case for Professor Hans Rosling's 200 countries and 200 years, where we have five-dimensional data variables. So if there is any design principle here, sure we have. Let's consider this example here. In this data table, we have two qualitative data variables, the animal and the zoo, plus one column of quantitative data variable. So for a given pair value of animal and zoo, there's a unique value mapping to that. Usually when we have multiple qualitative data variables, it's important to create a hierarchy for them. Like you have a main category, and under that main category you may have a subcategory. This is very like the pivotal table in Excel. So we may create a main category that is the zoo, and under each zoo we have various subcategory animals, or vice versa. The next, we can create an extended bar plot to visualize this. We may use a variation of bar plot to describe this three-dimensional data variable. In fact, you may pick either the grouped bar chart or a stacked bar chart. They both display the hierarchy between zoo and animals, but the first one is grouped side by side, and the second one is stacked together. Can you spot the different usage for them? You may pause here and think about it. Clearly, the first one is easier to compare the differences among different categories. And the second one, within the main category, you can spot the kind of share between a subcategory to the overall summation value. So that is the part to the whole ratio. Let's have a small test here. Suppose you have such a three-dimensional data table, two qualitative and one quantitative. Here, for a given pair value of animals and zoo, there are multiple values mapping to that. For example, the giraffe in the San Francisco Zoo have recorded different daily consumption on the food units. How do you decide the chart type? You may pause here and think about it. We can have a variation of the box plot where for each pair value, the animal and the zoo, we can use the box plot to describe the daily consumption distribution. Somewhat like this. So you will create some visualization graph like this one. You have the hierarchy here, the main category and the subcategory. And for this one, okay, within the main and the subcategory, you can describe the distribution using the box plot. The last case we want to discuss here is the bubble plot. That is what the Professor Hans Rosling did. Let's see how it works. Suppose you have been given a data table like this. You have multiple quantitative variables and qualitative variables. What we need to do is to first rank the data importance and map to the right visual cues. In Hans Rosling's data table, the most important one is the life expectancy and income per person. So we assign the X and Y position to them. Next, we have the total population with size and the world region with color. For random data table like this, you may assign the coordinate position to X and Y values, and the size of each data point for variable Z, the label of the category with text information. And this is a variation of scatter plot. We can have multiple additional dimensions of the data represented in different visual cues. A small quiz here. What does the size mean? This is clearly a bubble plot. Let's summarize this lesson on how to choosing the right chart type for a given data table. You may need to consider the data type, the relationships, and also the visual encodings together to finally decide the chart type. Anyway, practice makes perfect. Thanks for watching and enjoy your learning.